All right, today we are going to finally look at trigonometry. And don't let the name trigonometry scare you. I actually love these two sections, 9.9 and 9.10. It's going to give you a little introduction into what you'll be doing next year, some more of that. As it says right here, I'll just read it to you. Right triangles have many equations that help solve for missing pieces, including the Pythagorean theorem, and our special triangles of 30, 60, 90, and 45, 45, 90. So again, we're talking about right triangles here. If there isn't a special relationship between the angles, there are three more ways to solve for missing pieces, including angles using trigonometry. Trig uses word problems often and is common on standardized tests. Totally true. So when we think about it, we have three ways that we've been solving. So number one, we have the Pythagorean theorem. And that is when we have right triangles and we have two sides of a right triangle. And then we had our special triangles, special right triangles. And for that one, we could be given one side, but then we'd have to know if it's a 45, 45, 90, or a 30, 60, 90. So we'd have to be given the special right triangles. So finally, today we're going to be looking at trig. And for this one, you could be given one side and one angle, other than the right angle, of course. So we'll say of a right triangle. And so now with trig, we'll be able to solve for missing sides or missing angles given only one side and one angle, which we couldn't do. We couldn't solve anything like that before. Now, we already know that right triangles have a special relationship between the sides. And so for any right triangle that, just like the 30, 60, 90, or the 45, 45, and 45, 90, there are special ratios between the sides given specific angles. And so these ratios we call sine, cosine, and tangent. And we've defined those ratios. So in other words, the sine of an angle, now in this case it's all angle A is how it's defined. The sine of angle A, now with regard to angle A, this side here would be the opposite side. This side here would be the adjacent side. Adjacent usually means next to. And then C, of course, across from the right angle is our hypotenuse. So with regard to angle A, we have our opposite side, adjacent side, and hypotenuse side. So the sine of angle A is opposite over hypotenuse, and that's how we define the sine. The cosine of angle A, often abbreviated COS, cosine of A is equal to the adjacent side over the hypotenuse. And then finally, the tangent of A, abbreviated tan, is equal to the opposite over adjacent. Now, to help us remember this, we often use SOHCAHTOA. It sounds like some old Native American expression or something. SOHCAHTOA. So you can see that sine is opposite over hypotenuse, SOH. Cosine is adjacent over hypotenuse, CAH, and tangent is opposite over adjacent, and that's where the TOA comes from. So I would recommend you write SOHCAHTOA on the top of your paper as a reference to help you remember how we define sine, cosine, and tangent. And since there are specific values for these ratios with regard to specific angles, we can use sine, cosine, and tangent with our calculators to help us solve for missing sides and angles. Now, just a note of caution here. It says, like I marked the triangle above with regard to angle A. If we were talking about angle B here, This would be opposite for angle B. This would be adjacent for angle B, and hypotenuse is still hypotenuse. So pay attention to the sides opposite and adjacent with regard to the angle that's defined. Well, let's look at some examples. We need some letters here, so let's label this triangle. And we want to find the three trig ratios, first for angle A, and then for angle B. So we're going to do two different colors here. We'll start with blue for angle A. So I'm going to mark angle A right there. With regard to angle A, this would be the opposite. This would be the adjacent. This is the hypotenuse. And so sine of A is opposite over hypotenuse. And any fraction, we always simplify. So we rewrite that as 4/5. Cosine of A, adjacent over hypotenuse, simplified, 3/5. Tangent of A, opposite over adjacent, is 4/3. Now with angle B, hypotenuse is still hypotenuse, but this is now opposite. This is adjacent. So with regard to angle B, sine of angle B is 18/30, or 3/5. Cosine of angle B is 24/30, adjacent over hypotenuse, or 4/5. And tangent of angle B, opposite over, adjacent, and that is 3/4. So just getting you familiar with these ratios. So again, I'm just going to write this here, so we have it as we move up. So we want to find the sine of angle A. So with regard to angle A, this would be opposite. This is adjacent. This is hypotenuse. Oh, we need to find the hypotenuse first. We don't know it. It just says C. So let's find that. We know 5 squared plus 12 squared equals C squared. 25 plus 144 equals C squared. 169 equals C squared. C is 13. So this is 13. So now we can find sine of A is opposite over hypotenuse. Done. Can't be simplified. Cosine of A, adjacent over hypotenuse. Done. Can't do anything else. With regard to angle B, this is the opposite. This is the adjacent. So tangent of B, opposite over adjacent, and there we go. Can't be simplified. That's it. All right, now we have an isosceles triangle. So if we take that and we bring down, try that again. If we bring that down, we need to create a right triangle because we need a hypotenuse and, well, we need a right triangle to do trigonometry. So we're going to split that triangle in half. This would be 5 then. And just like the last example, we could solve for the height using Pythagorean theorem, but we already know from the last example, 5, 12, 13, it's just like the last one. That's a Pythagorean triple, so we'll just go with that. Now, we want to find the sine of angle C. So here's angle C right here. I'll just color it in. So with regard to angle C, this is hypotenuse. This is opposite. This is adjacent. So sine of C, opposite over hypotenuse. That is it. Now, everything we've done up to this point has just been writing and simplifying the fractions, the ratios with regard to sine, cosine, and tangent. But now in this problem, you're going to see how we can use trigonometry to solve for missing pieces. So first of all, I'm going to draw this straight down. This is our h. It's the same as what's drawn right there. But now I'm making the right triangle so we can see this measurement at the bottom is 50. We have our 40-degree angle and the height. So now I have this right triangle. And we want to know how tall the tree is. So we can't do Pythagorean or anything else. We only have one side and one angle. But we can do trig. Notice with regard to that 40-degree angle, this is opposite, this is adjacent. So which trig function uses opposite and adjacent? Tangent. So we can write tangent of 40 degrees is equal to opposite over adjacent. And now to solve this equation for h, we're going to multiply both sides by 50. And so in other words, h is equal to 50 times the tangent of 40 degrees. Now that we're putting this in here, make sure your calculator is in degrees and not radians. If you have a graphing calculator, push the mode button. Make sure it's degrees and not radians. But we're going to punch that in our calculator. 50 tangent of 40, rounded to the nearest foot as it told us to. The height of the tree would be approximately 42 feet tall. Now this one was relatively easy to solve because our variable was on the top of the fraction. I want you to suppose, just as an example, what if we had to solve this equation that looked like sine of 20 degrees equals 10 over x? Well, now in this case, we can't just multiply both sides by 10 or so forth. I like to think of these like a cross product. In other words, I put a 1 under the sine of 20 and think x times sine of 20 is equal to 10 times 1 or 10. Now I'm going to divide both sides by sine of 20 degrees. So x equals 10 divided by sine of 20 degrees. And if you put that in your calculator, you get approximately 29.2. So if your variable's in the denominator, it's a little bit more work, or maybe you'll just start remembering it's, they kind of x and the sign or whatever it might be, whatever your trig function kind of swap places. All right, enjoy your homework.